Hello, my dear students. Welcome to succeedsmart.com. In this session, let's explore Rutherford's atomic model. This atomic model was proposed by a famous scientist known as Ernest Rutherford in the year 1911. His atomic model is based on an experiment known as alpha ray scattering experiment. Before going into the experiment performed by Rutherford, we should know what is meant by alpha ray, what is meant by scattering. Coming towards alpha rays, generally some radioactive elements releases three types of rays, which are known as alpha rays, beta rays, and gamma rays. Alpha rays contains a stream of alpha particles traveling in straight lines. Now these alpha particles are also known as He2 plus particles. Beta rays contains beta particles which are moving as a stream in straight lines. These beta particles are also known as electrons. Coming towards gamma rays doesn't contain any particles in it, but it contains small energy packets known as photons. These photons are not the particles, just these are energy packets present in gamma rays. Now, in order to know detailed explanation about experiment performed by Rutherford, let us explore what are alpha particles, because this experiment performed by Rutherford is mainly based on alpha rays. Therefore, it is necessary to learn what are alpha particles. As I said earlier, alpha particles are also known as He2 plus particles. Now there is a doubt how this He2 plus particle is formed. If you take in case of an element helium, atomic number is 2. This shows that it contains 2 protons, 2 electrons, and it also contains 2 neutrons. 2 protons and 2 neutrons are present in a specific region inside the atom known as nucleus, whereas these 2 electrons will be revolving around the nucleus. Coming towards geometrical representation of helium atom, as I said earlier, it contains a central region known as nucleus containing 2 protons and 2 neutrons, and it contains 2 electrons revolving around the nucleus. Now from this helium, if you remove 2 electrons, now it gets converted into He2 plus. This 2 plus indicates that it has lost 2 electrons. When it loses 2 electrons, these 2 electrons will not be there in helium. Now it contains only 2 protons and 2 neutrons. Now, if you observe in geometrical structure, if you remove these 2 electrons, now it contains only 2 protons as well as 2 neutrons, and it doesn't contain any electron. We know that electron revolves around the nucleus in specified path known as orbit. As long as there is electron, you can see the orbit. When there is no electron, orbit also not visible. Now this particle is nothing but known as He2 plus particle. Now we shall see what are the properties of this He2 plus particle. As I said earlier, this He2 plus particle contains only 2 protons, 2 neutrons, and it doesn't contain any electrons. As these electrons carry negative charge, when there are no electrons in He2 plus, therefore negatively charged is not there in He2 plus. and these two neutrons also doesn't contribute anything or any charge to He2 plus because neutrons carry zero charge. Now it contains two protons. We know that protons carry positive charge. Therefore we can say that He2 plus is having charge and He2 plus is having positive charge because of the presence of these two protons. Coming towards the next property of He2 plus, it has a mass of 4 amu. It travels with a velocity which is equal to 1 by 10th of velocity of light. Velocity of light. And these He2 plus particles, alpha particles which are present in alpha rays, has very low penetration power. Penetration power. Now you can observe in this diagram, it is having only the nucleus but doesn't contain any orbit. Therefore this is also known as helium nucleus because this is the nucleus of helium. Now coming towards experiment performed by Rutherford. As I said earlier, Rutherford performed an experiment known as alpha ray scattering experiment. In this experiment, first we shall see what are the raw materials that are used. First one is gold foil. Second one is zinc sulfide screen. And third one is, as usual, as I said earlier, alpha rays. Now what is the use of using this gold foil? What is meant by foil? Foil is nothing but any thin sheet of any substance is known as foil. Why he used only gold foil means the only element in the periodic table which can be converted into very thin sheet is gold. Therefore, we can say that it can be converted into very thin sheets having a thickness of approximately 100 nanometers. And he used zinc sulfide screen. The use of zinc sulfide screen is we can't see alpha rays, but their presence can be detected by the presence of this zinc sulfide screen. Therefore, we can say that this zinc sulfide screen detects alpha rays. Now just we shall see the pictorial representation or diagrammatical representation of alpha ray scattering experiment. I have already said that he has taken a gold foil. Just we shall assume this is gold foil. Behind this gold foil, just he kept a screen known as zinc sulfide screen. And he passed rays known as alpha rays. Now we shall go through an animated video so that you will get more information on the experiment performed by Rutherford. Now if you see this animated video, you can observe few things. Just assume that this rectangular section is a gold foil. We shall assume that this gold foil is made up of a single atom, and you can observe a blue dot revolving here, which is nothing but we shall assume it as electron. Now here you can see blue dot represents electron, red dot represents proton, and grey dot represents neutron, and a combination of red and grey dot represents alpha particle. Now as I said earlier, Rutherford has passed alpha particles through the gold foil. Now you can observe that alpha rays are passing through the gold foil. Now we shall see what are the observations that are made by Rutherford. First observation is, you can observe that the rays which are passing through the atom, most of the rays are not getting deflected. Just they are passing through the atom in a straight way and they are falling on zinc sulfide screen. This shows that most of the portion of the atom is empty. That's why the rays are passing through the atom without any deflection. But if you observe the rays which are moving towards center of the atom, they are getting deflected from their path. Now you can observe that the core part, here you can observe the rays are getting deflected from their original path. Now there is a doubt why the rays are getting deflected. As I said earlier, He2 plus particles possess positive charge, whereas the protons which are concentrated at the center also contains positive charge. Therefore, in between positively charged protons and positively charged He2 plus, there arises repulsions. Because of these repulsions, they are deviating from their path. Therefore, we can say by this, at the center, it contains protons. Now, if you observe in this animated diagram, the rays which are moving towards the center are getting deflected from their path, and the rays which are moving far away from the nucleus are going in a straight path. Now we shall write down the observations that are made by Rutherford. First observation is, he observed that most of the rays are passing through the atom without any deflection. Therefore, he says that most of the portion of atom is empty. Most of the portion of atom is empty. And second observation, those rays which are moving towards the center of the atom are getting deflected or deviated from their path. This shows that protons are present at the center. Coming towards third observation, we know that mass of proton is equal to 1837 times more than mass of electron, and mass of neutron is equal to 1839 times more than that of mass of electron. Therefore, these protons and neutrons are present at the center. Therefore, we can say the total weight of the atom is concentrated at the center, known as nucleus. Again, I am repeating this. Proton is having a very high mass when compared to electron, and neutron is also having very high mass when compared to that of electron, and these two particles are present at the center. Therefore, we can say total weight is concentrated at center, known as nucleus. Now coming towards next observation, you can observe that now that gold foil contains protons and neutrons at the center and electron is revolving around the nucleus. Now when electron is revolving around the nucleus, it experiences two types of forces. The force which is acting out is known as centrifugal force, and the force which is acting inside is known as centripetal force. Now these two forces are equal. That means centrifugal force is equal to centripetal force, and these two forces will act in opposite directions. Therefore, this electron will be in revolving condition. And he compared the revolving of electron around the nucleus with revolving of planets around the sun. Therefore, we can say that this Rutherford's atomic model is comparable, or it can be compared to solar system. This means that electrons revolve around the nucleus just as planets revolve around the sun. Therefore, this atomic model is also known as planetary model. I hope in this session You understood well about Rutherford's atomic model. In next session, you will learn about what are the defects of Rutherford's atomic model and what are the modifications